Oh, hello and welcome back to NodeConf Remote. Right now we have Karin Angel, and Karin is an experienced software engineer with expertise in building high-scale, highly available performance systems using microservice architectures in Node.js. She's a great believer in testing, specifically the microservice architectures, and she hopes to pass on this passion to others in the community. So please give a warm virtual welcome to Karin with microservice architecture in Node.js automated testing.
Hi everyone. So today we're going to talk about how we will test our microservices architecture in Node.js and basically in every platform, and how we are going to make this whole process cost effective. So first, I'm going to have a few words about me. So I am a developer for as long as I remember myself, and in the past 5 years, I've been focusing on Node.js. On my spare time, I really love to travel, to paint, and to have a few drinks. So our agenda for today's talk is going to be a short overview of microservices architecture. Why is testing difficult in microservices architecture? We're gonna introduce a little bit the differences between unit tests and API tests in terms of cost efficiency of the tests. We're gonna talk about the importance of integration tests, and at the end, I'm gonna give you a tip. So microservices architecture, right? It's a software development technique, which allows you to build fine-grained, loosely coupled services. They're organized around the business capabilities. They have interfaces which they communicate with. The communication is over technology agnostic protocols, and it has a lot of more to it. A sketch of this kind of a system would look like something like this. You have some kind of a user interface that talks to an API gateway. The API gateway gets the request, understands it, and sends it to the correct microservice. Microservices can talk to each other, and each and every one of them has their own database, which they can query in order to do some job and then to reply to the user. As I said, microservices architecture has a lot of benefits. These are only some of them, right? They enable modularity. They make it easy to integrate with legacy systems. They allow distributed development, so you can develop parallelly different microservices. They allow easily scalability. And they're very efficient, right? But when you're dealing with microservices architecture, you have to take into consideration some aspects, and the aspect that we're talking today about is the testing aspect, which can be very complicated, and we're gonna understand as long as we proceed. So for the rest of the talk, I want to consider a food delivery app. Okay, we are developers in a food delivery app, which is built on top of microservices architecture, and we're hired to the Scooter MS, the Scooter microservice team, and this is the team we're developing on. And on the first day in our job, they're asking us, okay, we want you to add a feature to the Scooter microservice. We need to add live location to each scooter. So the Scooter MS has a database of scooters with scooter table, and we decide that we will save the live location of a scooter to that table. And let's assume that we have already developed this capability, and now we want to build tests in order to push it to production, right? We need to test what we wrote. So the easiest thing to do, the fastest thing to do, is to write unit tests, right? So unit tests, as we know, it's a testing method, which is testing individual sections of the application, which called units. And each unit is tested whether it fits or not the purpose that it was written for. So a unit is commonly a function or a procedure. It allows us to comprehensively test complex application by building blocks of tests. Each test case should be tested independently in order to isolate issues. And we use stubs and mocks in order to assist test the module in isolation. So unit test has a lot of benefits. First, we can find the problems early in the development cycle. We are writing the code, running a test, and have a feedback, right? Also, because they're on the function level or on the procedure level, they make it easy to trace the location of the failure. Also, they provide some kind of a living documentation of a system. I guess that every one of you had installed a module, and the first thing you do to learn that module or how it works, you go to the tests, right, in order to see how you are initiating or how you're starting to run the code. And it also ensures modules to work after a refactor or an upgrade in a later date. So let's say we are adding unit tests to our food delivery app, and we're testing the ability to update live location of a scooter. So the first thing I'm doing is creating a scooter. The second thing is I am updating the longitude and latitude for that scooter. The third thing that I'm doing is querying the database, checking the database, asking the database what is the information of that scooter, and then I am checking whether the update occurred. And as I repeatedly said, I'm querying the database. And as this one unit test that I have a lot of more unit tests, all querying the database. But 1 month later, we've become bigger. We have a lot of scooters, a lot of drivers. We have decided that we want to change the implementation of the live location of scooters. So now we want to shift from the database to Redis. But what about our unit tests? They were querying the database. Now we'll have to change all of them to query Redis. And changing tests, it's a good scenario. The bad scenario would be that we will have to rewrite the entire test suite. So what if we wrote API tests in the first place? So API tests are much like unit tests, but they're basically testing your application on the API level. It's business logic oriented. Okay, so it tests whether business logic through the API actually had happened. And much like unit tests, again, each test case should be tested independently in order to isolate issues, and we again using stubs and mocks in order to test a module in isolation. API tests a lot of benefits as unit tests, but the key differentiator here is that it is tolerant to underlying implementation changes. So if we have a little comparison between the two, so the API tests are at the API level, they're higher in the hierarchy. They're business logic oriented. There are fewer tests to be written because we don't need to test edge cases that are not interesting. If the business logic is not going to go there, why to test it in the first place? And again, it's tolerant to implementation changes. It doesn't care what is the underlying implementation, whether we were using some kind of a database like Mongo or whatever, or moved to Redis, it doesn't care. We're testing on the API level. On the other hand, unit tests allow us to test the functions themselves, and they allow an easier location of the failure. We can locate the failure more easily. So which one should we use? I say use both. You should cover your APIs with API tests really comprehensively. And only the critical or crucial functions that you have that are on the critical path of your application, you should test for edge cases. Not every function needs to be tested with all of its edge cases. So if we go back to our food delivery app, I would have written the test in the first place like this. I would have created a scooter, then I would have updated it, and then I would have queried the API. So all of these requests are API requests that I'm doing. And I would have written all my tests through the API, and then these kind of changes of using different database or using a different storage wouldn't affect the tests. And you can think of more examples for this. Okay, so 1 month later, again, we want to change the implementation of Scooter live locations again. We've decided that the Scooter live location is taking the entire logic is taking a lot of space in the Scooter MS, so we're moving it to a different service altogether. And the Scooter live location MS exposes an API to initialize the live location of a scooter with a specific state, and we are on the Scooter MS team and we're consuming that API. So we need to specify the latitude and longitude in the body of the request, and we need to specify the state in the query string of the request. And again, we in the Scooter MS team are consuming this API. So let's say this is a piece of code that in which we are consuming the API. See, I have here the Scooter live location network, and I'm doing an update of a scooter with the state and latitude and longitude. So this is a piece of code in which I'm consuming the Scooter live location service. And now I want to test it, right? So I need to write a test. And see, I am passing the state, the latitude, and longitude in the body of the request. So, okay, let's proceed with this code, and I'm writing a test. So in order to test, I am writing a mock for the live location service. And I'm saying, so with this test, I'm gonna send this and this state, latitude and longitude. And again, I'm sending it in the body of the mock because my code is actually going to do that. But if you remember, we said that the API of the Scooter live location is expecting the state in the query string. So what we're gonna have here is the tests are gonna pass because I had a bug in my code in Scooter MS, and I continued that bug into the test, and I wrote tests that correspond with my buggy code. The tests are going to pass. But when we'll go to production, it's not gonna work because the integration between the Scooter MS and the Scooter live location MS is wrong. One was sending some data through the body of a request, and the other one was expecting it to be on a query string. So it's not going to work, although all the tests have passed. So for that, we need integration tests. So basically, integration test is combining few modules or few services and testing them all together. Basically, testing if they perform the needed business flow. Again, all the microservices that are tested within the test need to be brought up for the testing. The benefits are, like, the key differentiator here is that integration tests expose faults in the interaction between the units. Why not do only integration tests? Again, they are very late in the developing process. They consume more time to write, to set up, and to run. They make it harder to locate the root cause of the fault. You don't know where in the chain of event there was the problem. Because we need to set up the entire environment, it's a higher cost. And this one I already said. So a testing process in terms of cost efficiency should look something like this. While you're developing, you want to have a fast feedback from your tests, whether your code is working or not in the capsule of this microservice. So you should write unit tests again for your critical code, for your crucial functions that maybe they're making a complex calculation or something like that, but there are functions that you don't really need to have unit tests for. They will be tested through your comprehensive API tests as long as the flow is working correctly. They will be tested. And right before you're deploying your new code, again, run the unit tests, the comprehensive API tests, and here you're gonna run the integration test that you've written. And this is how a good testing process of microservices architecture should look like. So up till now, we talked about pre-production tests. What's about after we're releasing? So post-production testing, and this is the bit I wanted to talk about. So post-production testing is basically an approach of testing and monitoring your production environment. So first of all, you're going to ask me, why should we test our production environment? Why is it necessary? We invested so much in testing up till now. So first of all, you all should know that we cannot test everything. If you've shipped a product, you missed a bug. Each and every one of you, if you have clients, they've called you, they told you something is not working correctly. So if you did post-production testing, you might have seen that bug before the client would have. And also, testing and staging environments are never identical to production. It's like comparing a zoo to nature. In production, you have real user requests, you have latency of the databases, and when you're testing, you're using stubs, while in production, that stub is not, there is no stub, okay? So the stub is being written by you. It can be buggy, it can be different than the real production component that you're stubbing. And it could work differently. So I think that I made my point why you should do post-production testing, and you should use it. Don't only do that, right? You should use it as a complementary solution to the pre-production testing. So there are some practices of production. So we have Canary testing. Basically, it means if you have several machines with the same service, change only one replica and see and navigate the network to that some of your network to that replica, and then see how it behaves and have some kind of statistics over it. Control test flight is basically the same thing with users, only expose a small group of users to changes or to new changes in your code and see how it behaves. These two approaches are good if you have a lot of network requests or a lot of users, because you're only sending a small portion of them, and you need to have a significant amount in order to have a good statistics. What you should do if you don't have a lot of users or a lot of network, use synthetic user testing. Basically, it means make fake users and write some scripts for them to do so in your system, and see how it behaves, and then you'll have statistics. And the last practice I have here is fault injection. Basically, it means create problems within your production environment, and see how gracefully this problem that you've created is handled. Basically, you can do something. You can pull down an entire service, or take out a database, or have a lot of network, so have load on your system, and see how your system is handling everything. This practice is being used by Netflix with its Kiosk Monkey routine. So to sum up, we should use the best of all worlds in order to test our system, but we should do it in a smart way. We don't want to add unit tests for everything. We only want to test our critical functions with them. We will comprehensively test our APIs, because our business logic is the important part of the system. And then we will add integration tests of business flows to our microservices, in order to see that the business flows are working correctly. And at the end, after we shipped to production, we will test in production, of course. That was me. If you have any questions, I'm here for you.
Okay, thank you very much. That was really, really interesting, Karin. I was particularly interested in the testing and production side of it. I had an amazing bug recently, which was a cache bleed issue that only showed up in production. And it does sometimes that's the only place you're going to catch those sorts of things. So hearing all those sorts of ideas about how you can try and mitigate against those sorts of problems was really interesting. Thank you. So I have some questions for you. So first off, we have one from Antonio. Let me bring it over here so I can read it. Antonio says, one of the hardest things to test in a microservice architecture, from his experience, or from their experience rather, is testing the asynchronous processes, so the event-driven architecture. Have you faced this situation?
So I would say, well, it depends. The asynchronous processes, I guess it's between the microservices themselves, as I understand. So sometimes we want to add stubs for the tests. The other thing that we can do is to have the tests running, and then to wait for the asynchronous reaction to happen, and then to kind of call the response. That's from my experience, that's the things that we did up till now.
Okay, thank you. So say I had one microservice and I was splitting it into two microservices. What would happen with the tests in that situation?
Okay. So, as I said before, if you write good tests or you write in a comprehensive way your APIs, then if you have one microservice and then you split it into two, then some of the logic will go to one microservice and the other logic would go to a different microservice. So you can like 80% or 90% of the tests of the API test, you'll just have to copy and paste to that different microservice that now you have splitted. And maybe you will have to add a little bit more tests, and also the tests are going with the code that had went. And again, you'll have to add integration tests for these two microservices that are now interacting with each other.
Mm-hmm. So you're testing the contract between the two new microservices as well as the internals of it.
Exactly. So if you've written from the beginning the API test correctly, then you'll split it into these two microservices, and then you'll have to add the integration, the contract, exactly, the API between the two, that they're working correctly with each other.
Okay, thank you. So we touched on the sort of problems that I personally encountered in production, but what sort of issues have you encountered in post-production tests?
What kind of problems did I encounter in post-production?
Yes.
So one time I actually encountered a problem that if we had a Canary release, then we would understand that we would go back, fix our problems. One of the things at the beginning, when we are a small startup, you don't have a lot of money or time to invest on integration. You're testing more your each and every service, but you don't have a lot of time to invest on integration because at the beginning you don't really have clients. The only ones that are facing the problems are actually the developers themselves. So you're not investing on integration. And then we had a lot of problems there. One developer was developing one microservice. The APIs were building as we were going. We were just talking like you and I, hey, dude, what this API is looking like? And he was telling to me, we are human beings, we were writing code. And then at production, it wouldn't work correctly, but because the loop was really, really small, we could fix it really fast. When we went to the stage that we have users, then we understood that we must add integration tests and post-production tests. Because one time, for instance, I was testing against a false database, okay? And a database that I have, like the tests are not really also in the integration phase and on unit tests and API tests. It's a false database, right? It's not the database of production. One of the components that we have written wasn't working so well on production, and there was some kind of performance issue because there were a lot of drivers, for instance. So we had to add some kind of pagination or some sort of that thing to solve it. And if we had a test flight or some kind of a Canary release, we could have understood that issue on our own before the clients.
Okay. Well, thank you very much, Karin. That was great. And thank you very much for your talk.